Hi, greetings, everyone. This is Pete Murray with the City Networks Task Force. We're going to get started in about a minute or two with the call. I'll be kicking it off, and then I'll be handing it off to the team in Arizona with Dr. Larry Head from the University of Arizona and Jen Toothaker from the Department of Transportation in Tucson, Arizona. So just bear with us for a minute. And we're also going to unmute Jen if we can.
Sounds like you did it.
Oh, terrific. There you go. Good. I was hoping to hear from you, Jen. So yeah, we're going to get started in just a moment. So just bear with us for about one more minute. I take it your whole team's there together?
We are. Daryl is, I saw an email that he's logging in, and I believe is getting the pin so he can be unmuted for his part of the presentation.
Good. Okay, so I see people logging in still, but my screen should be up. There we go. Let's see. We'll just do that for now. Okay, so we're going to go ahead and get started. Again, I'm Pete Murray with the City Networks Task Force. Is a collaboration between the Wireless Infrastructure Association and the Smart Cities Council. We've got a full agenda coming up this fall of events. So we're looking forward to you all joining us and participating in some of our other sessions and helping to create content. We've been creating content for the past few months. Maybe you've seen our piece on Lake Nona. On any case, I am just experiencing one little technical difficulty here in changing the screen, so bear with me. There we go. Okay, so in any case, we have, as I said, we have a slate of webinars coming up. August 16th, we'll have a telecommunications policy update with Jonathan Adelstein, the president of the Wireless Infrastructure Association. Doug Dimitrov, who is an attorney with Phillips Lytle, but he sits on he is the chair of the subcommittee on state and local policy for broadband deployment. So he's got a big update on what the FCC is recommending and what some of the trends are out in the marketplace. And Rebecca Hunter from External Affairs at Crown Castle will moderate the call. We also have a call on September 25th, Greenfield Smart Community Infrastructure. We're going to overview the Lake Nona community in Florida, and we'll also look at Pena Station in Denver, and you can see some of the talent we have there. The next big upcoming event is October 2nd through 4th in Washington, D.C., Smart Cities Week. So if you want to register for that, please go to the Smart City Council page, or we have a link now from the new City Networks Task Force website. So here you can see the new domain. That's kind of in beta form, but it's up and running now. So please take a look. And as well, our YouTube channel is now got 6 videos posted, and we'll start posting more content regularly in the coming weeks. So looking forward to that. Pardon me again, I'm having technical difficulty. There we go. Lastly, before we get into the main part of the content here, I want to mention the Telecommunications Education Center, which is one of the key resources that we draw on for information. They can be found at tec-online.org, and they've got some of the leading programs on the kind of hands-on nitty-gritty of the wireless industry, and you can see some of the programs from 5G Outlook, DAS and small cell, and something very important now is site safety. So we'll be going ahead with that. And that said, I want to be able to hand this off to Jen. Jen, can you hear me?
I sure can. Thanks,
Now I just want to see if you can put your slides up, or if I'm going to need to go ahead and move
Can you
forward.
share the screen? Let us share our screen.
Yeah. Okay. Let's see if I can get that to work. Okay. So with that, I don't believe I can share to your screen, unfortunately. So if it's possible, can you all see my screen?
Yes.
Yeah. Okay. So if you don't mind, just go next, and we're in the interest of time and convenience here.
Absolutely.
All right. Thank you so much. So I'm handing off to Jen Toothaker to lead us through the project manager with the Tucson Department of Transportation. Thanks, Jen.
Thank you, Peter. I have the luxury of being able to give you some updates about what we're doing in the southern Arizona region. And I'm joined today with Dr. Larry Head, who works at the University of Arizona in the leading the Transportation Research Institute and also acting interim dean at the Department of Civil Engineering. We also have Daryl Keaton joining us from Phoenix, representing his company, Sensigrate, which is a new company, a startup company looking at infrastructure to vehicle infrastructure. I'll start with giving a government perspective, and then Larry will talk a bit about the emerging technologies, and then again, Daryl will speak to information to vehicle technology from his perspective. Next.
I'm moving here. Sorry. Bear with me.
No worries.
There we go. Having a little bit of technical difficulties with this.
Okay.
Go ahead.
You can sort of see the map here, which just shows Arizona, and you'll notice that Tucson is in the southern Arizona region. We're about 120 miles south of Phoenix, which is Arizona. We're a city of about 237 square miles. We have over 500,000 in our city boundaries, and in our metro boundaries, we're about 850,000. Next. Are you able to advance it forward?
I did. Are you not seeing Select Smart Initiatives in Arizona?
There it is. To orient everyone, Arizona, there's a lot going on in Arizona, not just in our region, which we're focusing on today, but in the broader region, we have a lot happening on the border. Arizona-Mexico Smart Border Project. Bill Gates, you may have read, late last year purchased 25,000 acres, which will become a future smart city along Interstate 11, which is the new Canamex corridor, which the alignments are still being set and construction scheduled to begin years away from now. We have Local Motors in Phoenix, which is a 3D printing manufacturer of autonomous vehicles. They have vehicles out and operating. They've won competitions that DARPA has sponsored. And also, you know, probably the most that people have heard is about the autonomous vehicle testing that's happening in the Phoenix area. Waymo, Uber have been out testing their vehicles on the roads. Part of the reason we are becoming so popular for AV testing is that Governor Ducey is really supporting it through Executive Order 2015-09, which allows the testing on the roadways, and also by not requiring a lot of the permits and paperwork that other states are. Next. In our region, we have some projects going on, proving grounds for testing of autonomous vehicles, or we're doing that at Musselman Honda Circuit Track and U of A Tech Park at Rita Ranch. They'll be doing an expansion to include intelligent roadway and testing environments. The picture that you see racing the sun is an example of education programs that challenge students at the college level, high school level, pardon me, Larry just corrected me, to build and operate solar-powered go-karts. And this year, for the first time, they did autonomous solar-powered go-karts and racing. Our Pima Association of Governments is leading a smart community task force that involves community stakeholders, businesses, and jurisdictions. We have data and communications infrastructure inventory project going on that's public and private infrastructure that is GIS-based and capturing a lot of data behind that. And in the future, we have the Sonoran Corridor, which is a freight bypass to the southeast of Tucson that is intended to also be a smart roadway. Next. Partnerships are huge for us down here, and U of A Tech Park has been convening a group, the Smart Vehicles and Intelligent Transportation team, for a few years now. That includes government, research and development, industry, technology and business development, workforce education, and also beginning to involve utilities. Next. From the City of Tucson perspective, we are working hard to identify what are the smart city initiatives underway. Just identifying them to raise awareness within the organization is an effort we've been doing now for about a year. Our initial accomplishments include an inventory list of projects, and really what we can use that for is to begin looking at where do opportunities exist to co-invest, to work together across the different departments, and also where is there room for P3s to come into play. An important thing to note is that our city manager's office has established the Office of Innovation and Strategy. That just happened within about a month. So that is very exciting to have it at that level in our organization. It just bodes well for our future. Next, please. And the different types of initiatives that we have going on in the City of Tucson include things like smart water readers, water line monitors. We have LED streetlights that have been placed in. And of course, with that Office of Innovation and Strategy, we're looking to create a culture of innovation. What I'll be speaking a little bit about is our Department of Transportation priorities. And among them include our Tucson DOT drone program, the smart mobility that's occurring in our region, of which Tucson is a partner, our regional traffic data network, and the Living Lab, which includes our innovation and deployment districts. Next. Tucson's DOT drone program has licensed 3 individuals within Department of Transportation. The city is self-insuring for the drone program. We're able to use video that we shoot to capture progress updates and make available through our social media on capital projects and various things that we need the taxpayers to be aware of so they know what we are doing with their money. We are also using them for things, the bottom right shows an image where we can do before and after studies on changes that we make to traffic signals. And in this instance, we made a traffic signal change on left turns, and we did a before and after, and immediately we're able, through viewing the video, to see what the impacts on the roadway from literally a bird's eye view are. And that, what we've realized from that is an immediacy, because we're able to do it in-house. The level of information is high quality, and it's giving us other options as well. If you'll go to the next slide, we are able to do our own internal mapping and surveying using the drone, which is saving us person hours out in the field. It's literally making a process that can take up to 2 to 3 weeks. It's happening overnight. The images on the left, the map, that aerial was created with 3,500 images taken from a drone flight in one day. It was processed overnight to create a 4D digital surface model, which was able to give us floodplain mapping to the high level of accuracy that we ground truth. It's exciting to be able to use this type of technology in this way. Next. One thing that we're recognizing with the drone, for example, is while we're capturing that data and that information and keeping it on board the drone, there are the options of being able to transmit that data through any number of options of communication networks. This slide just kind of drives home the point that there's a number of ways that we are transmitting data. Next. And our Smart Mobility program, which has a number of infrastructure elements. We have, of course, our roadways, and by creating our transit system and bike share and giving information out to travelers, we're helping to try to uncongest our roadways. We're trying to give information to people so that they can make better decisions about how they get around, and perhaps that will be not in their single occupant vehicle. We have at the top of the screen images that indicate the amount of data that's available is using the cloud. We have apps, and we have smart parking meters. We have real-time traffic management. We also have private sector peer-to-peer things going on, Zipcar, the car sharing economy. But most important for today's discussion, which Dr. Head will be speaking to, is really that autonomous vehicle research and development and deployment that's happening here, and our connected vehicle research and development and deployment. Next. One element to the work we're doing internally at City of Tucson is identifying what are the different devices we have working for us. So this slide just goes to show the different types of equipment we have working for us and what are the types of network connections that they're utilizing. Next. And as mentioned, one of our priorities is our regional traffic data network and the communications equipment. And that takes a lot of information compilation. We're using GIS to bring together different data sets and visualize it to allow us to do better planning and decision making. Our regional traffic data network, if you can see on the next slide, involves a series of different connections to our enterprise fiber system, with some of our communication systems doing multiple jumps, being able to give us that kind of communication network to transmit small packets of data. We also have the larger cell type tower connections, and then we have smaller mesh network pieces to that. Our TDN system is a legacy system. It was originally built in the 1980s and is in transition, and a big question that we have is, what are we transitioning to? And that's a planning process that we're currently working on. Next. And through partnership with the U of A, also that's been in place since 1980, we've got the Living Lab project that allows us to focus in on different corridors highlighted in yellow here. You'll see the U of A Tech Park and the Musselman Honda Circuit Track to the bottom left of the screen. Those are those autonomous proving grounds that we talked about. These roadways that are highlighted in yellow indicate areas where we are prioritizing our communications equipment and our sort of entrepreneurial innovation environment to let us create these connected vehicle and autonomous vehicle corridor environments. And the next slide, which concludes my piece of this, is honing in on the government issues and considerations related to the communication networks. On the private side, we've had at the state level 2 bills that have gotten passed by our Arizona State Legislature, House Bill 2365 and 1140. 2365 focuses on the small cell wireless technology facilities permits and fees for installation of these private equipments in the public right-of-way and on our property. House Bill 1140 is new. It will be effectuated in 2019, and that's oriented for cable and video companies' permits and fees to use public right-of-way. It also controls the rates that governments can assess for that installation. Both of these bills have come from the top down. They have involved all of the cities and counties to work on a shot clock to process these applications. They're really oriented at letting Arizona become a leader in the deployment of these technologies to support a smart city future. The challenge that we're having at the local level is that it has really stripped the local government of a lot of authority and control, and I'll just mention that if there are more questions about that, we can always provide more information. The FirstNet Responders Network is something that is a federal project, and that has also had implications on us. The federal contract award to AT&T has gotten AT&T out into the states. They are really looking to build out in 5 years their 5G network. We, at Arizona state level, the governor has given all the jurisdictions choice to use the federal program or to use their own provider of choice. I believe our local region is opted to stay with our provider, Verizon, for now, as Verizon has been trying to also be competitive to the federal AT&T FirstNet program. And then just briefly on the public sector side of it, a lot of this is just creating absolutely new paradigms. The cybersecurity and operations, when we're looking at these communication systems, most of them have been set up as separate systems, independent of each other, but as we're looking to the future, do they need to stay separate? Are we able to allocate or share the bandwidth? Which also means that opens up opportunities for co-investing, and not just within our organization, but also with private sector. Planning, implementing, and funding, this is huge. We have multiple jurisdictions all trying to learn to work together, plan together. We have multiple departments trying to figure out how to move forward and how to get the equipment that we need and the service that we need. And we also, to add to that, land use and development has a role in this as well. How do we build the communities that we need into the future? And so while we're looking at the roadways and transportation, that land use piece is very significant. A lot happens at that point as well. Data as a utility or data as a service, who has access to what and how is that obtained, through whose networks? Where is that data stored? Who's managing it? Those are all things that are just, really, we're grappling with those. And then public access, public Wi-Fi. So these are issues and considerations that City of Tucson's working through. I'd like to, if Daryl Keaton is available on the line, if he can be unmuted, we have a few slides for him.
Can you talk for Daryl?
Yeah, the Tracy is probably working on that right now.
Great. Well, I'll share just the reason we've asked Daryl to join on. I'll kind of talk until you can get him on the line. In our Living Lab corridors, we are looking to partner up with Sensigrate to allow him to test in a real-world setting his technology, which is that infrastructure to vehicle communication. And what Dr. Head will be speaking to is kind of that communication that's happening from the vehicle to the infrastructure. And if we aren't able to get Daryl to speak immediately, we can go ahead and maybe have Dr. Head speak.
Daryl should be on.
I'm here. Can you hear me?
Yes. Great to hear you.
Thank you, Jennifer.
Okay.
Thanks, Jennifer. Hello, my name is Daryl Keaton, founder and president of Sensigrate. Sensigrate is a industry-defining smart city infrastructure to vehicle, or I2V, communication platform that provides data to support intelligent decision-making for human-driven and autonomous vehicles to foster safer interaction as they navigate our roadways. I2V may be new to you. For some of you on the call, and you're probably familiar more with V2V and V2I and V2X, but I'll get into more details defining that. So with smart cities and the data developed from IoT devices and sensors and other solutions will be vital to creating efficiencies. A key component for transportation will be innovation pertaining to the discussions today and smart infrastructure. Smart infrastructure is sensing technologies embedded in infrastructure and the equipment it interacts with. These sensors are connected to a communication backbone, which allows real-time data acquisitions and analysis. The information is gathered and analyzed, interpreted, and delivered as reliable, robust, and meaningful information to infrastructure providers who can make better informed decisions about the structural health and maintenance of their assets, and especially our transportation system and infrastructure. In this image, you can see some examples within smart infrastructure that pertains to transportation. Within V2X, which Dr. Lorryhead will discuss further, there are many applications and solutions that are in development or will be developed based on new risk exposures and helping solve the vision of zero deaths of the world's roads. In addition to this form of communication is at SensorGrate, we are fostering infrastructure to vehicle communications as we believe it is a key component to a connected and automated vehicle corridors. V2I is a wireless exchange of smart data from the transportation infrastructure to vehicles. The communication is intended primarily to provide critical safety, operational data from IoT sensors, and data collected from the infrastructure. The data prevents and detects risks that may cause vehicle collisions to provide decisions to safer solutions. These benefits will include providing communications to vehicles for warnings, alerts, provide real-time traffic data, and smart data and analytics to municipalities, communities, and OEMs and other parties. So why is this important? By 2040, it's estimated that 95% of new vehicles sold, or 96.3 million cars, will be fully autonomous. The risk is we have human drivers driving on the same road with self-driving vehicles and connected vehicles, but the human-driven vehicles may not talk with them. So we see our solution as a risk solution to help prevent and detect threats, warnings, and alerts and dangers to make sure that these vehicles are able to share the road safely and more efficiently. So what's really next in the era of this innovation is education and awareness to primary and secondary parties who will benefit from established, connected, and automated vehicle environments. These technologies as a whole are vital to smart city and connected and automated vehicle planning and readiness. So this photo here is from the U.S. Department of Transportation, kind of gives you a visualization from what a connected and automated vehicle environment looks like. And I believe next will be Dr. Lorryhead talking about feature development.
Great, thanks, Daryl. So Daryl kind of gave you the background on the I2V part, and Jen gave you an overview of where the city is and what they're thinking about. And so we've been exploring different possibilities of technology that can allow us to make impacts in cities like Tucson and other places. And really the focus of what I'm going to talk about is on transportation, but when we talk about vehicle to vehicle, vehicle to infrastructure, other technologies, backhaul and such, it really becomes an integrated network for general applications. It's supported by the transportation network. And I'm going to focus a little bit on the connected and automated vehicle side of it. So next slide. So I like to use this slide just to give people a definition for what connected vehicles are. Vehicles equipped with devices that allow them to communicate data called a basic safety message between the two vehicles 10 times a second. This information then allows the vehicles to have applications that can make the vehicle safer. And so this was all made possible in 1999 when the FCC allocated 75 megahertz of the spectrum at 5.9 gigahertz. And a technology has been developed since then called dedicated short-range communication, and with the purpose of supporting safety, mobility, and environmental applications. And these basic safety messages, and there's a whole family of messages, but the basic safety message really gives you high-fidelity information about where a vehicle is located. It has a temporary ID that changes every so often to ensure privacy. It has position information and a GPS coordinate system. It has information about the motion of the vehicle, like the speed, the heading, acceleration, steering wheel angle, what the brakes are doing, the size of the vehicle, and the mode of the vehicle. So for the first time in transportation, we actually know, is that a Class 8 truck coming down the road, or is that a passenger vehicle, or a transit vehicle, or a truck? So one of the next slide, please. One of the really key things to, this says IntelliDrive, this got an old word on the slide, but this is a slide USDOT published in 2007. And the goal was to show the latency and how long it takes a message to go from origin to destination, or end-to-end communication latency. And if you use satellites or cellular or other kind of technologies that existed in 2007, you can see the latency in seconds is generally greater than 1 second. People think information comes to them really quickly, but if you go and conduct an experiment and measure point-to-point message transmission times, it's generally not as fast as you think. A second is pretty fast to humans. But when you want to do things like safety applications, you really need to be sub-second level, or really less than like 2/100ths of a second is the most stringent active safety application that's out there. It's for pre-crash sensing. Two vehicles, one passing another vehicle on an open road, traveling 60 miles an hour, they need to know pretty quickly that there's something going on. And if you see at the very bottom, that's where the DSRC, the dedicated short-range communication, is at 0.2 of a millisecond. So it's really, really fast communication, and these small messages that move really quickly across this part of the spectrum. So the next slide shows how that 5.9 gigahertz spectrum was broken out by the FCC in the regulation, and it's broken into several different channels. Channel 172 is sort of the really important channel. It's called the Safety of Life and Property channel, and that's where basic safety messages and other messages called MAP and SPAT are transmitted. The MAP message is a very small message that describes the geometry of roadway sections or intersections, and the SPAT is a signal phase and timing data that comes out of a traffic signal controller 10 times a second. And then channel 178 is called the control channel, and that's where a thing called a wave service announcement is broadcast. And so if a vehicle is traveling down the road and they pick up something on channel 178 and it's a wave service announcement and it says, today we're offering special service for priority eligible vehicles at traffic signals, for example, please switch to channel 182. Then the radio can switch to 182 and send messages like signal request messages and signal status messages that go back and forth between priority eligible vehicles. There's a whole host of applications, 57 different applications that I'm aware of that use the different channels for supporting different kinds of safety of life, mobility, and environmental applications. Channel 184 is a special channel, and it's been set aside by the FCC for public service and emergency applications. And so it's called the high power long range. You're allowed to broadcast messages at a higher power because they bleed over into the other channels that are there. And so this sort of basic channelization of the spectrum that's been provided for transportation is really key in designing the next generation system. Next slide. Sorry. So, like Daryl hinted to, if we're able to get the vehicles to talk to each other, maybe we can have the vehicles talk to the infrastructure. Sorry, my voice is going for reasons I don't know why. So things like traffic signal systems is what we work on. So the vehicles like a fire vehicle, a truck, a passenger vehicle, a transit vehicle can communicate with the infrastructure and tell the infrastructure, I'm a really important transit vehicle and I'm behind schedule and I'd like to get through the intersection. Or I'm an emergency vehicle and I'm in emergency response mode. I really need special provisions to get me through the signal and get rid of the cars that are in the queue. And all that's made available through roadside equipment and standards that have been defined to have the messages and the communications. Next slide, please. So if you just think this slide is just to make you think a little bit of, if you're in our business of doing things in transportation and traffic management, what could you do if you had this kind of data? Well, the first thing that we think of you can do is a phrase coined by my colleagues at Berkeley is performance observation. We can measure travel time, delay stops, arrival on red, arrival on green, queue length. We can do it by movement and by mode. So if you have an intersection where you have a lot of trucks that are turning left, they're going to take a lot longer to make the left-hand turn than, say, Ferraris and motorcycles will. So, you can then begin to really characterize the performance of the system with the different kind of vehicles. We don't have the capability to do this today. So that's really interesting. And then just doing better traffic control. I don't know how many of you have ever sat at a traffic signal and wondered why it's red, right? Or be more adaptive to changing flow in traffic. Or what we focus on mostly today is those special modes of vehicles. So the next slide talks about a project. There's a pool fund project, and the pool fund for this group is a group of state and local agencies that have funded research projects in this idea of connected vehicles. There's several different pool funds, but in the Connected Vehicle Pool Fund, Federal Highway Administration, which is a federal agency, Maricopa County DOT, California DOT, Virginia, Florida, Minnesota, Texas, have all pooled their money to support the research. And it's a joint effort between the University of Arizona and the University of California, Berkeley PATH program to develop a system called the Multimodal Intelligent Traffic Signal System. And the goal of this system is to use this connected vehicle data to make traffic signals operate more efficiently, but also much safer. We operate 2 test beds in the program. One is in Maricopa County near Phoenix and Anthem, Arizona, and one is in Palo Alto, right on the edge of Stanford University, where we actually do testing and demonstrations of the program. It's about a 7-year-old program now, and we're in phase 3, which is improving the product to be deployment readiness. So if we can have the next slide. So normally if I do this in an animated way with PowerPoint, I give you a feeling. You're the little car on the left, and you're driving down the road and something happens ahead, and through either infrastructure systems or vehicle-to-vehicle systems, you could receive a warning in the car that says, oh, there's an incident ahead, be alert. It's contextually correct, it's situationally aware, that's the information you need. Then you get these 2 emergency vehicles that might be coming at the signal from different directions, and we talked to several different agencies about this, and they said, don't worry, this never happens. We never have 2 fire trucks at a traffic signal at the same time. But it really does happen, and so if we could alert the passenger vehicles and the other emergency vehicles about the oncoming emergency vehicles through vehicle-to-vehicle or vehicle-to-infrastructure type communication, then we can do something smart with the traffic signal, and then all kinds of other information that's out there, like a school zone alert. Why don't we just provide that to your vehicle at times when it's situationally relevant? School zone signs are out in the middle of the night, but there's no school zone in the middle of the night, right? And so drivers are always busy processing all the information in the roadway, trying to figure out what's irrelevant. If we could let you know there's a work zone ahead and the queue is spilling back and the lanes are merging, then we can do things to make work zones much more efficient. So next slide. Every time I get a chance to talk to groups like this, I really like to harp on this emergency vehicle situation, because it turns out that more firefighters die in traffic accidents than die fighting fires. The number 1 cause of death for firefighters is cancer. The number 2 cause of death is traffic accidents. So if you can show the next slide, that would be useful. There we go. Oh, okay. Well, I have a picture on the previous slide that shows an intersection in Houston from March 30th, 2009, where 2 fire trucks were on their way to a false alarm, and they collided. And it turned out that both drivers thought they were going to get a green light because the traffic signal had this fancy stuff called preemption. It turns out preemption is not really very smart, and so we could do a much better job. And the other day when I was updating slides for this talk, I wondered, well, I wonder if there's been a lot more of these since 2009. And I have a whole collection of them. But when I went to Google and Googled it, look at the number that came up just in 2 pages of pictures that are available. And this happens all the time. And so it really is time for us to use the technology that we have available to make this safer. So I'll get off my soapbox, and I want to talk a little bit about the infrastructure needs to support connected vehicles, which is the next slide, please. This just shows a picture of the living lab here in Tucson, Arizona on the bottom. It's a Google map that we took, and it shows about a 3-mile stretch of Speedway Boulevard in Tucson and our planned locations to put DSRC radios. So on the top, it shows a couple of radios networked together to a management system and also to a security certificate management system. The SCMS is, now you can get it commercially available to be able to get the signatures that you need to attach to each message so that when somebody receives one of these broadcast messages, they know that it's authentic. And what we're trying to show on the bottom is that we have a fiber run down Speedway, and everywhere there's an intersection or a node where we can connect one of the radios, there's a green circle. And the circle is shown to be 300 meters in radius. And 300 meters is what the FCC is in the regulation says is the minimum communication distance of one of these devices installed in the roadway. So you can kind of get a vision for what it takes to get coverage and how many radios that we have to have there. The yellow that are there are locations where we would like to have a radio to make sure we have coverage where we don't actually have network access at that point. And the red one is a location that we would really like to have where we don't even have power. So we need power and we need network connection to be able to operate the radios. Now, clearly the radios operate over the wireless to the vehicles, but once you get information to the radio on the roadside, then it can go back to the management system. So if I could see the next one. If this group is not familiar with something called the SPAT Challenge, there's a group through the National Operations Center of Excellence that was set up by USDOT, was previously called the V2I Deployment Coalition. And the goal was to deploy 20 intersections in all 50 states by 2020. And I updated this slide a couple of days ago, and it's not even really fully relevant, but the dark blue highlights that are there show the locations that meet the challenge goal of 20 intersections. And you can see we don't have all 50 states, and we have some gaps like Texas, where we know they're doing things, and Portland, Maine, where we're standing up a new project. But this was to be there because what comes first? Do we equip the vehicles or do we equip the infrastructure? And the infrastructure owner operators wanted the vehicle manufacturers to know we really believe in the technology and we're coming on board and we're doing this deployment. And so as of last month, we're way past the 1,000 intersections in the US. We'll probably by the 2020 goal be closer to 4,000 intersections in the US through this program. And it's been really exciting to have all of the infrastructure operators. So let's talk a little bit about the impact on the next slide. This is just a map that we put together based upon our connected vehicle traffic signal system called MITS. I didn't get to choose the name, by the way, but that's what the feds decided to call it. And so we have systems operational in Maricopa County and Utah. We also have one in California, which for some reason I didn't get on the map. But we're talking about projects in San Diego, Portland, and Columbus, Ohio. In Florida, they have the connected vehicle pilot that is using the MITS system. And by the way, the Portland project, I should have updated the color of that. That's under contract now and will be operational soon. So I just think it's interesting that we're beginning to see the deployment of the technology through the SPAT Challenge. We're beginning to see some agencies adopt and try to use the research, the MITS project that we have. So let's see the next slide for the future roadmap. I tried to put this together to talk to this group specifically in terms of the near future, midterm, and long-term future. And so between today and about 2020, and when 2020, I don't mean you'll take it out in 2020, it'll go for a long time, we can do connected vehicles using DSRC. We can equip special fleets of vehicles, transit vehicles and trucks and emergency vehicles that are out there. Partially it's very exciting because General Motors made a commitment, even without a federal mandate, in 2017 to begin selling vehicles into the market. The Cadillac CTS, they sold 5,000 of them in 2017 that were equipped. Earlier this year, Toyota and Lexus announced that even though they have 100,000 vehicles operating in Japan, in 2021, the vehicles sold in the US will be equipped with the technology. And then you can buy roadside units available today, and you can run traffic signal applications like MITs and others that have been developed on them. If we think a little further into what's next between 2020 and say 2028, I chose it because it's 10 years out, there's discussion of a competing technology to DSRC that's called cellular V2X, and it really is a deployment of the LTE that you're used to with your cell phone in the 5.9 gigahertz spectrum. It's possible. The federal mandate or the federal regulation would have to change to get it done, but there's a lot of work going on and some standards committees and things being stood up to do it. So you might have vehicles that use this technology, either connected or possibly even automated vehicles to get it. And then infrastructure roadside units are, there are none of these units available today, but they could be based on the cellular V2X technology like we're using today. Using the RSUs we're using today. And then long term, those connected vehicles with cellular V2X and or maybe 5G, when 5G becomes available, we can have connected and automated vehicles, perhaps streaming data from the vehicles. We can have infrastructure roadside units that are equipped with 5G that can do 10 to 20 gigabytes per second of communication of data. So streaming LiDAR data off of a vehicle is fully possible. There's high capacity backhaul to connect these together. One of my colleagues has developed a technology called wave division multiplexing, Dan Kilper, where it's actually 10 terabytes per second per square kilometer. And it's just really, really exciting. And then instead of having data centers in the cloud in Nebraska in a farm, you're going to actually have them in the urban area. And we'll be able to stream the data to these data centers and process it. So the next slide is one I borrowed from Qualcomm, who's working really hard on the V2X technology. If we could see that, it kind of explains a little bit about the difference between the UU interface, which is going through the cellular system to do things, and the PC5 interface, which allows vehicles to communicate. And so someday our cell phones could be equipped with this technology, so pedestrians and bicycles and others would be very easy to get into the system, and we can become aware. And so you can have both of these direct and network communications available. The next slide from Qualcomm. Yeah, I think it's a duplicate, so just move on, please, to the infrastructure needs. So I tried to go back to the picture that I showed before and just really talk about, you need some form of network. Originally, to talk to the SCMS, it had to be IPv6, but now they're supporting IPv4 technology. We've seen in California in the test bed, they're using cellular 4G technology to do it when the data demands are very low, but you're going to need fiber if you're going to move sensor data and other kind of data around. And I didn't get a chance to update the slide of the figure on the bottom, but think about those being 1/3 the size, being 100 meters, not 300 meters. So the small cell technology is going to require an awful lot of connection points in the network. So if we could go to the next slide. Just really quick, I want to show small cells, 5G, large backhaul, different applications that could be out there. The infrastructure V2I, things like curb speed warning, roadway safety, and maybe information used for automated vehicles. And I think we're getting tight on time, and I want to make sure that we have time for TU Simple. But if you can really quick go through the next couple slides, the automated slide, just think about the kind of information that's available. Go on to the challenges. Think about the automated vehicles that have had trouble going through traffic signals. I think we can all probably Google the internet, or I find out if you use Bing, you find more of them because a lot of them are Waymo. Go on to the next one, the emergency vehicle challenges that I highlighted before. This is a picture of the Tesla vehicle that ran into the fire truck in California. They don't necessarily obey the driving rules. The fire trucks don't. And so the Tesla vehicle didn't think it was really there. Go on to the next one. Simple vehicle-to-vehicle communication can address those things. So if we could integrate these technologies and go to the next one, the federal guidance slide. We have guidance for each of these. Now we need to have guidance for bringing them together and having connected and automated vehicles. And then if we get to the long-term opportunities on the next slide, sorry, I'm trying to go a little quicker. But just imagine if we could have sort of this virtual situational awareness from the vehicle streaming their data, infrastructure-based sensors, really painting the picture of what's going on in the real world. We'd have a real-time, situation-aware, monitored and controlled system. We'll know where the pedestrians, the bicycles, and the vehicles are going to be and where they can possibly interact. And then my final slide is to show you this Tech Park Research Living Lab that we're developing, where we intend to do exactly this. And so we've spec'd out a piece of roadway at our tech park. We're deploying fiber. We're deploying all this, a data center that's there with some data center partner I can't really name, but you can think about who they are, with the fiber communication that Dan Kilper has developed. And so it's an exciting time, and the future has a lot of potential possibilities. So now I want to quickly turn it over to TU Simple.
And that's Chuck Price, who's joined us today.
Great.
And hopefully you have Chuck's slides, Peter.
I'm getting there. Bear with me 1 second, please.
Chuck, do you want to start and give us a little information about yourself?
Sure. I'm Chuck Price. I'm Vice President of Product for TU Simple, which means my responsibility is to define our production product and deliver that product to the market. To that end, I will talk extensively about the company as we get to the slides.
Yes. How long is TU Simple?
It's going to take me a moment to load that. Bear with me. I'm sorry. It's in my email.
Okay. So I'll go ahead and cover some of the topics that you will see on the slides when they show up. The first is, I don't know if everyone is aware of sort of the size of the trucking industry, but it is a massive industry. It is a $700 billion annual revenue market in the U.S. alone. And to put that into context, it is almost double the size of the internet software market. It is huge. There are four major pain points that we address as a company. Thank you. There's the slide. The trucking industry is a high capital investment, low margin industry. The operating costs are tremendous. Typically they're earning pennies on the dollar. 10% profit would be fabulous for most fleets. About 40% of the direct operating cost is labor. That sort of trades with fuel. Sometimes fuel is the highest, but typically labor is the highest cost. Fuel is second, tires are third. There is lots of energy wasted along the way. Of course, there are safety issues with crashes. Most significantly, there's a tremendous driver shortage, and that's really what's motivating the drive towards automation. It's not so much to replace labor. It's to allow freights and shippers to be able to serve the needs, the demand that is not being met today because of lack of drivers. We also believe that with automation, we can tremendously improve sort of the environmental footprint of trucks. Next slide. Our company is almost 3 years old now. I have a habit of saying 2 years old, and so now we're almost 3. We have about 350 employees worldwide. We are focusing on the two top trucking markets in the world, the U.S. and China. We're in our third round of funding. We've raised $83 million to date. we are, by multiple measures, the largest company focused directly and exclusively on trucks. Ours is the largest focused initiative amongst all of the competitors in trucks. That includes Waymo, Uber, and the smaller players, Embark and Starsky and others, and Daimler and the large OEMs. Our solution is a level 4. Next slide. We're doing an SAE level 4 fully driverless autonomous vehicle in certain domains. If you're unfamiliar with the SAE levels, I'm showing them on the slide, where level 0 is nothing, you're driving your car. Level 5 is sort of the mythical infinity of a vehicle can operate in any environment at any time for any reason. We believe that is sort of an ideal goal which will never actually be achieved, at least in our lifetime. We are focused on level 4, which is really where it makes sense. That is where we can operate in certain defined domains. We can remove the driver from the loop, which provides a number of advantages, including tremendous fuel savings, which I'll be able to talk about if you ask some questions on this. I won't be able to cover it in the slides, but let's talk about our domain. The next slides. So a level 4 operates on defined domains. Our defined domains are dock-to-dock full automation. So unlike, I believe, all of the other players in the space with trucks, which are focusing on the highway, we're going beyond the highway. So it's on highway, near highway surface streets, to near highway distribution centers, and all the way to the loading dock. So the goal is to provide a solution that fully, seamlessly integrates with existing fleets and logistical operations, fully integrates with the supply chain. We have a second product, which is a port drayage autonomous truck, and that moves containers from the ship to the stacks and from the ship to close locations near ports. This is in live operation today in South Dian, China, and we are about to go live in the largest port in China, the Shanghai port, through a cooperative agreement. This has been operating fully driver out for probably about 6 months now in daily operation. So there is no driver in the seat in the port. We can do that because it's private land. Someday we hope to do that in other areas. I have some material that is not on the slide, so just hold it here for a moment. Our system is a multi-sensor fusion-based solution, but unlike most of our competitors, our primary sensor is an array of cameras. Our primary sensor is not LiDAR. However, we do integrate with radar, ultrasonics, and LiDAR for certain use cases. Because of the choice of the design and the technology we've applied, we are the world leader in sensing range. Our vehicles can perceive much farther than vehicles that are using, for example, LiDAR as a primary sensor. That typically will give you about 150 meters of range practically, although they'll claim 200 to 250, and some Waymo claims 300. You can see a dot at that range, but you can't actually identify and track an object at 300 meters with LiDAR in our experience. With our systems, we are out to 500 meters today, and we're going to be making some announcements shortly about some dramatic improvements in our range. We believe that the 300, 500 meter range is critical for operating trucks safely at 65 miles an hour on highways. You need that range to be able to make good decisions with trucks. Cars are a little different story, but trucks, it's important to have that range. We are a map-based solution, meaning we run mapping vehicles on the routes that we're going to run to generate a high-definition map before we operate on that route. We generate our own maps. They're highly proprietary, loaded with nuggets of information that we generate. We believe it's better to pre-compute as much as you can to minimize the errors the vehicles make when they're dynamically operating on the highway. As a company, just to put ourselves in perspective, we have 266 patents filed today on our technology, and because we're a new company and we filed a lot of patents, not many of them have been granted yet. We're about 20 patents have actually been granted so far. Last slide, we're not doing this alone. We have some great collaborations today with truck OEMs. In the U.S., we're working with Peterbilt. In China, we're working with Shaanxi Automobile Group, which is the Shackman brand. We're also working with FAW, which is those are the two largest producers in China. We're also working with Hino. We're working with many Tier 1 suppliers, Bendix, Wabco, Sony, Bosch. You can read the slides for the connectivity that we do inside the vehicle. NVIDIA is one of our investors. NVIDIA is a critical element of doing autonomous technologies, because ours is a neural network-based solution, and neural networks run best on NVIDIA. I guess that's an advertisement. I didn't mean to do that, but they're an investor. We do a tremendous amount of work on AWS with our simulation. Our insurance carrier is AIG, and we've been doing a lot of work with them on liability issues and such. And we're working deeply with the University of Arizona, various activities with the university. So that's too simple in a nutshell.
Thank you. Peter, I know there's not a lot of time left, but any questions?
Yeah, excuse me, there sure is. That was a power-packed hour of information. I really appreciate it. So I want to, thank Chuck and Daryl and Dr. Head and yourself, Jen, first of all. But one of the kind of rubber meets the road, pardon the pun, kind of issues is, we talk about the DSRC and then 5G. I saw Dr. Head kind of had 5G out about 10 years before anything practical. But in terms of the infrastructure and building blocks, you talked about infrastructure and roadside units and the edge. What's got to happen physically around the roadways in order to enable the type of networks that are going to be needed, whether it's DSRC or it's 5G, to bring the vision to life?
So the DSRC technology actually works pretty well in the roadway if your deployment is at intersections, because you already typically have power and networking. If you have a roadside location where there's a curve warning or something, you have to be able to get power and some form of communications, whether it's cellular or a network node. So, that's pretty good. When you move into the 5G type technology, it's a small cell technology. It's 100 meters. And so if you're going to get the same kind of coverage that you get with DSRC, and our DSRC units, we're getting in the order of a kilometer at the power allowed by the FCC, you're going to have fiber pole boxes and nodes all along every light pole. And we don't have that today. The street lighting systems in cities and the communication system are quite separate. And so somebody's going to have to be thinking about, as we install the fiber, building in the pole boxes and the access points of the fiber all the way down through the urban environment. And this is a huge change in how we do things today. So, we're going to see demonstrations of 5G. We're going to see projects. We're going to see some interesting small deployments. But when you really are going to see it on an urban-wide scale, this is a big deal. So I suspect early deployments are going to use some of the 5G wireless, the 10 to 20 gigabyte, to move some of the data around. But when you start moving large amounts of data, you need to have the fiber back end. If you really think you want to stream sensor data from vehicles and send it back to a data center, you're going to have large bandwidth infrastructure. So that's why, our team has been working on the 10 terabyte solution.
Yeah, well, I mean, I think that's going to be the $1 trillion issue, right, in terms of infrastructure here. In terms of practically, though, will DSRC be able to, down every turnpike and every roadway, will that infrastructure be able to be built subsidized strictly because of transportation, or will the kind of cross-subsidized 5G type of network ultimately be able to be proved in from an ROI type of analysis?
Yeah, I think your point is really well thought out. It's going to be a hybrid system. When you want to do things with the very low latency, vehicle to vehicle and vehicle to infrastructure, with the low latency for safety applications, technology like DSRC is going to be what you need. But you want to do bigger things, even curve speed warnings and other map information and such. It can come through 5G type of technology when it becomes available. Right, we're going to live in a 4G LTE world for a while still. So I think someday it's going to be a hybrid of communication technologies, and I don't think there's any intention by anybody to completely cover the world in DSRC. But I do think the public agencies are very interested in equipping their traffic signals and other roadway devices, freeways, ramp meters, variable message signs. These are easy places for them to deploy the technology, and it's not that expensive.
So from I think a number of the folks on the call here are in the engineering and integration type roles. What would you recommend? What skill sets are going to are in short supply now? What should be developing out there?
Yeah, so I think it goes all the way from our transportation planners and infrastructure designers, getting them a better understanding of the technology. So when we do roadway improvement projects, they know how to plan for the infrastructure communication, the nodes and the access points and the things that are there. Most of our IT professionals, I think, are pretty savvy in this kind of networking technology. They're going to have to learn about, what happens at the very high frequencies for 5G and how to install and operate these. But I'm confident that the cellular manufacturers are going to cover that part. On the vehicle side, I think we have a big gap. We don't have, technicians working in auto dealerships that can service these kind of vehicles. That are going to be equipped with either 5G, cellular V2X, or DSRC devices. So being able to understand how they operate, how to test them, how to repair them when they're not working, how to configure them, and on top of all of this, the whole cybersecurity and doing the security certificates, the revocation list, and all those kind of parts of the system are critical. We have a lot of work to do to prepare the workforce for what's going to be here in the next 10 to 20 years.
Yeah, well, that's one of the goals of the City Networks Task Force is to try and cross-pollinate from different silos or different expertise. So I think you've really helped extend your knowledge here. The whole group has. And it's appreciated. Jen, you talked about PPPs and the Office of Innovation and creating kind of a new role. What do you see? What role? How necessary are these kind of cooperative PPPs? And then a kind of a champion, a live human who owns sort of getting all these different organizations to grow into a common vision and actionable work. How's that developed and how important is it? I
would say from our experience in the organization, no one person has all the information. There's no one person that can do it alone, and it really is about identifying who has the right skill sets, the right knowledge, and bringing people together within the organization. So it's important, yes, to have our champions, and we do have champions at our elected level and within the organization. The manager's office being behind it is important across our organization and I think regionally. But I would say that we have our colleagues that are in IT that are the ones that are working most directly with a lot of these vendors in transportation. However, like Sensigrate, we have opportunities to work with these emerging tech, groups that are starting up and creating these new types of technologies that need to be tested, and we have the opportunity to create partnerships and allow it's actually creating industry within our region as well, and that's something U of A Tech Park has been instrumental in supporting. Too Simple as an example. So we have this new emerging company bringing these autonomous freight companies coming globally from China to Arizona, and so we've got through that smart vehicle and intelligent transportation group a number of people that we can go to that can help in this sort of ecosystem. So U of A Tech Park supporting these innovative startup companies by allowing us to provide some space for them to get real-world experience, and working through our living labs, we're creating an opportunity for economic development and industry development here in Arizona. So I don't know if I answered your question really well, but I think that the importance is extremely high. I'm passionate about this. I think that it's coming. We can't avoid it, and we need to be getting ourselves educated and getting positioned so that we're not having it done onto us, but figuring out how it's a win-win-win for everybody.
Yeah, well, it's certainly a time of huge change and huge opportunity. Hopefully, we all harness the potential because the safety ramifications alone are significant. So, all right, well, we've kind of run over, but I think it was useful, and I greatly appreciate, on behalf again of the WIA and the Smart City Council, we wanted to thank you, you good folks in Arizona. Chuck, I take it you're in Arizona as well. Thank you very much.
Probably the piece I missed is that we have a major development and test facility here in Tucson where we're building a substantial truck fleet. In fact, in the coming year, we're going to be building out 200 trucks, sort of centralized in Tucson, spreading out over Texas, potentially Florida, and some other adjacent states.
So it's coming.
It's coming. We'll be operating fully autonomous trucks, pulling live cargo with several major shippers starting later this year. So it's very fast. Very fast.
Yeah, well, it's fascinating. My group has done work with the city of Orlando and Florida Polytech University here in Central Florida, and they've got proving grounds being built right now. But the Turnpike Authority's got an 18-wheeler actively going up and down the Turnpike right now, fully autonomous. Obviously with the, I guess you would call it stage 4. The driver's there, right, and ready to take control. But anyway, so we're going to see more and more of this, and the networking component is crucial. So all this good information will be posted. It'll be actually the first piece of core information from one of our events or webinars that we've posted. Will be posted to the City Networks Task Force site sometime next week. So if people want to review the presentation, unless there's an objection, we'll have that up there. Again, thanks very much, Jen, Dr. Head, Daryl, Chuck, and we'll catch up with you all down the road.
Thank you.
Thank you for this opportunity. It was great.
Yeah, well, we really appreciate it. Good stuff. All right, Trace, can you close this out, or I guess I do?
I can.
All right, great.
Okay, thank you everyone for joining, and like I said, the presentation will be available shortly.